Alright, so I'm making good use of my snow day and recording a video on some rectangle properties. Alright, so a rectangle is a parallelogram, so therefore it has all the same properties of a parallelogram, which means my opposite sides are parallel, so let's go ahead and mark those. It would help if I select the pin. Alright, here we go. So remember, we're going to use our chicken feet to represent parallel. And then we need some up here. Make sure you use more than one, since you already used one on the left and right side. Alright, your opposite sides are congruent, so we're going to use our tick marks. Boom, boom. 2 of them, and 2. Alright. The other thing that we have to remember about a parallelogram is your opposite angles are congruent, so C and R and T and E. Now, being that this is a rectangle, we actually know something even more important. We actually have 4 right angles as part of it being a rectangle. That's something that's very special in terms of rectangles. Another property of parallelograms is your next to each other angles add up to 180, which you can easily see that here because 90 plus 90 definitely gives you 180. Remember, the fancy name for next to each other angles are consecutive angles. The other thing that you need to remember about parallelograms is that your diagonals are bisected, which means Z is the midpoint of TE and Z is the midpoint of CR. Now, in a regular parallelogram, your diagonals are not congruent, but in order for something to be a rectangle, your diagonals actually are congruent. So that tells me that ZR is actually going to be congruent to TZ and CZ and ZE. Okay. Now, because of that, we actually have 2 sets of isosceles triangles. We have the top and the bottom, and we have the left and the right. Now, that tells us something special about our angles. So we have some congruent angles that are formed. So I've got 4 congruent pink ones. And then we'll do some light blue stars. Well, not really a good star. You get the idea? Snowflake for a snow day, I guess. Alright, and then the ones around Z, of course, we have some vertical angles. So let's go ahead and mark those guys. So the top and the bottom are going to be congruent, and then your left and your right are going to be congruent. So knowing just one of the angles, you can actually find out all of the missing ones. And so we're actually going to do that on the next page. We're going to do a few examples. Alright, so for the first example, they gave me TZ and CZ. Well, if you remember back to what we just did, we said that your diagonals are actually all going to be congruent to each other. So since TZ is talking about half a diagonal and CZ is talking about half a diagonal, I know that they have to be congruent to each other. So easy peasy, let's just go ahead and set them equal to each other. Now, sometimes what they do like to do is give you like half of your diagonal and then the whole piece. So it's usually just easier if you multiply the small one by 2, and then you can set up your equation. You can divide the big one in half if it's a number, that's easy, but if it is something like this where you have to do some algebra, then you'd be distributing a half, and then that gets into fractions, and we know how everyone feels about fractions. No bueno. Alright, so we're going to set them equal to each other. Alright, so easy algebra. Let's subtract 4x. So minus 4x. And over here we're going to subtract 4x. So we're just going to be left with an x. We got 7. Make that look like a 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 7. 7 = 2. So then we're going to subtract our 2 over to be with the 7, which will end up giving us x is 5. X is 5. Ooh, x is 5. There we go. All right, so let's actually take and plug that in because we're looking for CR, so this whole thing. So a good way to check is if you plug in your 5 for both of these, and you should get the same number, and we do. So 4 times 5 plus 7, we get 27. 5 times 5 plus 2, we get 27. All right, so since my little baby guys are 27, and I'm looking for the whole thing, what I'm going to do is actually add 27 plus 27, and 27 plus 27 gives me CR is 54. All right, let's go ahead and move on to example number 2. So what I'm actually going to do for example number 2, the first thing is add my known information to my picture. So they told me RTV is 22 degrees, so we have RTZ is 22 degrees. All right, so hopefully you remember from the beginning of this video where I told you that we have some congruent pieces. You can probably even still see it. All right, so 22 is in my snowflake spot, so I have 3 more 22s that I'm going to go ahead and add to my picture. So 22, another one, and one more. Okay, now that we have that, well, we know that since this is a rectangle that all my corners are 90, right? Right. So to get my pink dot, these guys, we're just going to do 90 subtract 22, and 90 subtract 22 is 68. So these are 68, 68, 68. 6 is a little crazy. There we go. Alright, now we have 2 out of the 3 angles for each of my triangles, right? So, and triangles, you should remember, are 180 degrees. Alright, so we can figure out this missing top and this missing bottom right here. All we have to do is add 22 and 22, which we get 44, and then 180 minus 44, we get 136. So we have 136, and they're vertical, alright? So this one is also 136. Alright, so you have 2 options for how to find this piece right here. You could do 68 plus 68 and then subtract that from 180. And 68 plus 68, hey, we get 136. The other thing that you can think about is we have a straight line right here, and straight lines are 180 degrees. So if I subtract 136 from 180, I get 44. All right. Which something kind of cool, I don't know if you noticed it, 22 plus 22 is 44. I don't know if you remember the exterior angle theorem in a triangle. It says your 2 insides that are far away, when you add them up, it equals your outside tail. But hey, kind of cool trick. Everything comes together. Alright, so now we just have to fill in our chart. ZER, so ZER is 68. ZRE is 68. TZR is 136. Let's see, CZE, also 136. Alright, TZC is 44. RZE, 44. I think this is the hardest part for me, writing this down with its pen. ZRT is 22. ZTC, 68. ZCT, also 68. Two more. Alright. ZCE, we have 22. And then last but not least, ZEC is 22. Alright, not too bad. Alright, a little bit of a more tricky example. And I'm actually going to erase my picture so that I can draw some stuff on it. Alright, so a little bit more tricky, but honestly not too bad. So for this one, they are giving us TZR. So TZR is 120 degrees. Okay, so we got to do it a little bit backwards. So it'll probably be easiest if first things first we find the angles around Z. So this one right here is making a straight line. So 180 minus 120, we get 60. Not too bad. This one is vertical, so it's going to be 120. Okay, and then over here we have another vertical with our 60, so we have 60. Okay, so let's go ahead and jump back up to the one with the 120. So since this one is 120 and I have a triangle and I know that these two have to be congruent, what I'm going to do is 180 subtract 120, which gives me 60, and then I have to split that 60 in half. So half of 60 is 30, which tells me that these two little guys over here are both 30. Okay, now since I have the exact same triangle down here, exact same thing, 30 and 30. Okay, so let's do the same thing for my left and my right. So we have 180 subtract from 60, which gives me 120, and then I'm going to split my 120 in half. If I split 120 in half, I get 60 and 60. Now, the other thing that you could have done is, if you know that this is 30 and the whole corner has to be 90, 90 minus 30, hey, that's 60. All right, so that's another way that you could have done that. So now that we have our picture all filled out, we can go ahead and enter in the rest of these. So we have RTZ. So RTZ is 30. TRZ is 30. ZRE is 60. REZ is 60. RZE is also 60. TZC is 60. TCZ is also 60. This one's really nice. Most of the answers are 60. ZCE is 30. ZEC is 30. ZTC is 60. And CZE is 120. Alright, so I hope those few examples helped. Just keep in mind this picture right here. That'll help you pretty much figure out everything when it comes to rectangles. And the important thing to remember about rectangles is they are parallelograms with 4 right angles. and their diagonals are congruent.